This video shows the precision robotic assembly machine building a laser-driven fusion ignition target. The target has a tiny fuel capsule contained in a small gold cylinder the size of a pencil eraser. The laser beams of the National Ignition Facility, the world's largest and most energetic laser, will converge on the target and in 20 billionths of a second create a fusion ignition burn of the hydrogen fuel inside the capsule, creating a miniature sun on Earth. The construction of the target is complex. The components are aligned and fitted to each other with micrometer accuracy. The capsule is suspended in the central portion of the target by two plastic membranes on the ends of the upper and lower target halves. Here, we see the machine's manipulator system, which provides 100 nanometer precision control of millimeter scale components, releasing a target that was just assembled. Before starting to assemble a target, the manipulator system is turned on. The 2 millimeter diameter capsule and its glass fill tube, which tapers to 1/10 the thickness of a human hair, are fitted into the central portion of the target using a special fixture and transfer tooling. The transfer tooling is then loaded onto the machine. The lower half of the target is mounted onto its tooling and held with vacuum pressure. The lower target half is loaded onto the machine. Visible on the top of the target half is the 100 nanometer thick plastic membrane, or tent, that will suspend the capsule. The upper half of the target is loaded onto the machine in a similar fashion. This vacuum wand is used to center the capsule in the target. Here we see the vision system of the optical coordinate measuring machine focusing on a mirror that provides a side view of the target. The capsule and the central portion of the target are transferred to tooling on the machine. The thin vacuum wand passes through the central portion of the target and grabs the 2 millimeter diameter capsule. The lower half of the target is aligned to the capsule. Motion of the components is monitored with the vision system. The upper half of the target is aligned to the capsule in a similar fashion. The operator now drives the two target halves into the central portion of the target. Contact forces between the components are measured with 100 milligram resolution and displayed on the upper right monitor. The capsule is now being held by the two tents, and the vacuum wand that was holding it is retracted. Here we see the capsule being held by the two tents as the target halves complete their closure. While assembling the target, the operator uses force and torque feedback to monitor and control the final engagement of components that fit together with micrometer clearances. The vacuum tooling is retracted from the central portion of the target. Some of the auxiliary systems are removed and a steady rest is installed to assist the hand application of an epoxy that holds the target together. Here, we see a small drop of epoxy suspended on the end of a hair-thin applicator being applied to the target. An ultraviolet light is used to cure the epoxy. The free end of the capsule fill tube is grabbed by a manipulator. The capsule transfer tooling can now be removed. The target base is mounted to the machine. As the base is advanced towards the target, the 150 micrometer thin glass capsule fill tube is positioned to be inserted into a mating steel tube on the target base. Now that the fill tube is captured by the target base, the tooling that held its free end is removed. The base continues advancing to fully engage the ends of the target's cooling arms. The force and torque feedback is used to control the engagement between the target's fragile arms and the target base. Two clamps attach the target to the target base. The vacuum tooling that was holding the two target halves is released. Here, we see the laser fusion target that was built on the Precision Robotic Assembly machine at the Lawrence Livermore National Laboratory.